All right, folks. So back for the third part of the elasticities lecture, and this is slide 12. I wanted to go over a couple things that I think are really important to keep in mind when we calculate a price elasticity of demand. One of them is that for any straight line demand curve, the elasticity is going to change. Now, how is this different or how does this compare to a slope? Remember, if we have a straight line that represents a slope, we can take any two coordinates on that line and we will calculate the exact same slope. So this is another way that an elasticity differs from the slope of a line. The reason I'm telling you this is because many students will, again, like I say, get confused come exam time between how do you go about calculating elasticity and how do you go about calculating the slope. They'll fall back on what they're used to, which is the slope, because they've done that more often. They'll set up the problem wrong. They'll do all the calculations correctly, but they'll come out with the wrong answer. So I just want you to keep that in mind. Your elasticity will change for a straight line demand curve or supply curve, depending on which 2 points you choose. That should not happen if you're taking the slope of any straight line. So let's imagine that we compare the price elasticity of demand between V and W and T and U. So between V and W, there's a $1 difference in price. Between T and U, there's also a $1 difference in price. Between V and W, there's a 10 unit difference between quantities. Between T and U, there's also a 10 unit difference between quantities. If we were to go about calculating the price elasticity of demand between V and W using the midpoint formula, we would come up with the absolute value of negative 5.66. If we were to then make that same calculation, in other words, the price elasticity of demand using the midpoint formula, this time between T and U, we'd come out with a calculation that's the absolute value of negative 0.33. These are very, very different numbers, and one is what we call inelastic. This number over here, inelastic, meaning that its absolute value is between 0 and 1. And the other one is elastic, meaning that its absolute value is something greater than 1. So why is this? Because generally speaking, when our quantities are low and our prices are high, we're going to be on what we call the elastic portion of the demand curve. And if that's the portion of the demand curve you're on and your goal is to increase total revenue, then you should lower the price. That'll get more people to buy your product. If on the other hand, we're down here, let's say we're in this range between T and U, our prices are relatively low and our quantities are relatively high. So we're on the inelastic portion of the demand curve, and if our goal is to increase total revenue, then we should raise the price. What is the implication of this? What is the implication of having some range along the demand curve that is between 0 and 1 and some range along the demand curve that's greater than 1? It means that somewhere in the middle, we're going to transition from a number that's less than 1 to 1 before getting to a number that's greater than 1. And remember what I said about the significance of a price elasticity of demand of 1. That means a 1% increase in the price leads to 1% increase in 1% decrease in the price leads to 1% increase in the quantity demanded, which means no change in total revenue. Again, this oftentimes it could be the sweet spot in terms of pricing your product. All right, another thing I want you to keep in mind is that even though this formula for calculating the price elasticity of demand looks an awful lot like the slope, it's not the slope. So let's say we wanted to calculate both for this demand curve between 10,030 and 20,025. Those are the 2 points. Using the midpoint formula, I'm skipping all the steps here, but we did a calculation like this using the exact same number, so it's you can refer back to that if you want. Using the midpoint formula, the price elasticity of demand between these 2 points would be absolute value of negative 3.7. If, on the other hand, we wanted to calculate the slope of the line between these points, we would come up with a value of negative 0.0005. These two numbers are very, very different, and they're not even close. Yeah, this is the absolute. If we got rid of the absolute values signs here, this would be negative 3.7, and this is negative 0.005, but that's as close as they come, having negative signs. So do yourself a favor, make sure you set up the problem correctly. Over here, when we calculated the slope, we're doing rise over run, right? So we're picking our values to put in the numerator from the y-axis. Over here, when we're calculating the price elasticity of demand, we're taking our quantities, which are on the x-axis, and we're putting that in the numerator, and we're dividing it by our prices, which come off the y-axis, and we're putting that in the denominator. So if you set up the problem correctly, you shouldn't have a problem. If you don't set up the problem correctly, well, don't know what to say. All right, so let's talk about another elasticity. We're talking about things that will affect the price elasticity of demand. So what I want to do is I want to use an example of a product that most of us are familiar with. That is, let's say, the price of gasoline, and take a look at why we do what we do when the price of gasoline changes. So just imagine that tonight you go to sleep, and let's imagine that before you go to sleep, you didn't fill up your tank. You're close to E, but you'll do it tomorrow. It's not a big deal. Nothing's going to happen between now and the time you wake up, right? And just imagine that while you're sleeping, before you wake up, something crazy happens in the Middle East. Who knows? Trump does something, and all of a sudden the price of gasoline skyrockets by $3 a gallon in the time that you've been asleep. Okay. Let's run through each one of these things to see what your options are in the short run, and then we'll look at it in the short run versus the long run, and we'll see how that would affect the price elasticity of gasoline. So availability of substitutes. You folks live in San Diego County, North County. I know what transit's like there. It's not that good. Transit is not that much better here in San Diego where I live. So there aren't really too many good substitutes. Now, I've had students say, well, I'll just call Uber. Well, think about that for a moment. If you call Uber or Lyft because the price of gasoline has gone up, what do you think is going to happen to the fare that Uber or Lyft is going to charge you to take you from one place to another? I mean, these guys who are going to be driving you, they're going to have to pay higher prices for gasoline, so they're probably going to expect higher fares as well. Most of us don't live close enough to where we can walk or bicycle or skateboard to work. So, in reality, in the short run, there are very few substitutes. I mean, maybe you can carpool with a neighbor that's going in the same direction, but generally speaking, if you could do that, you would probably have already done that anyway. All right, so that means that in the short run, because there's not that much in the way of substitutes for gasoline, the price elasticity of demand is likely to be more inelastic. All right, necessities versus luxuries. What is gasoline? A necessity, something that you have to buy, or a luxury, something that you can go a long, long time, maybe your entire life without buying. And I don't know about you, but to me, it's a necessity. I mean, I don't know anybody that buys, let's say, gasoline for just for the sake of having gasoline. Usually we buy it because we're planning on using it up somehow. So necessities tend to have a higher price. The price elasticity demand tends to be more inelastic for necessities. All right, definition of a market. If we broaden our definition of a market, things tend to become more elastic. In other words, we tend to become more price sensitive. So, like an example I would use is if your definition of a market is urban San Diego County, you'll notice that the prices are a little bit higher, let's say, than if you were to go out to maybe East County, head in the direction of, like, I don't know, Santee or Hamul or someplace like that. The prices tend to go down a little bit more. And if you keep on going, let's say to Yuma, the prices are even lower. So why is that leading to bigger differences in price? Because we're defining our markets differently. A broader market definition tends to have a low. You tend to see lower price elasticities there. You tend to see more variation in the price because, in a confined market, the price elasticity of demand for any product tends to be more inelastic. Importance in a buyer's budget. Most of us, again, if we live here in suburban San Diego County, we drive everywhere. A lot of people don't like that, but that's just the way it is. So it's the importance of gasoline gasoline is likely to be more important in your budget compared to somebody who, let's say, lives in San Francisco and doesn't even own a car. Maybe if you live in San Francisco, you don't need a car because you've got BART, you've got the subway, you've got the bus, you've got all kinds of other options. So, somebody in a city like that or New York might say, well, what's the big deal that gasoline went up in price? It's not affecting me. Yeah, it's not affecting you because you don't buy it. But if you live here, or if you live in most parts of the country where you need a car to get from point A to point B, then it's probably going to be more important in your budget. And if you do a lot of driving, maybe for the kind of job you have or something like that, then it's going to seem more inelastic to you. All right, short run versus long run. In the short run, you probably have fewer options. In the long run, you generally have more options. So put yourself in this position. Imagine that you live in Temecula, you work in San Diego, you drive an SUV. Every day you make that big 60, 70 mile commute in each direction. And again, the price of gasoline goes up by $3 a gallon. In the short run, what are your options? And the option, you really can't do all that much. I mean, I guess you could put less gasoline in your tank each time you fill up, but that's not really an option because if you're going to be making that commute day after day after day, you're going to have to buy the gas at some point in time. In the long run, though, you have a lot more options. In the long run, if you've got an SUV, you could trade that in for a car that's more fuel efficient. You could trade it in for a Prius or something like that. If you're living in Temecula and you're working in San Diego, maybe you can find a job closer to home, so you don't have to make that commute. Or maybe you might decide, well, why don't I move closer to work? There's a lot of things that you can do in the long run that you can't do in the short run that would make the price elasticity of demand for gasoline more elastic. So just keep that in mind. All right, so I think we've pretty much killed it on the price elasticity of demand. There's a couple other elasticities that I want to go over. One is called the income elasticity of demand. That measures whether or not a good is a normal good, an inferior good, or a neutral good. And that's looking at the elasticity of demand in terms of changes in people's income. So in economics, we call this E sub y. Y is income. Then we've got another one called the cross price elasticity of demand, E sub x xz, if you like. That's how sensitive the demand for good X is given a change in the price of good Z. Okay, so in other words, if the price of good Z goes up and people buy more of good X and those two goods are substitutes, if the price of good Z goes up and people buy less of good X, then that means those goods are complements. We'll go through calculating these in a moment as well. So if you're going to calculate, and by the way, you don't have to do it on the exam per se, there will be, I'm just letting you know, there will be a price elasticity of demand calculation on the exam, but not a income elasticity of demand calculation. If you're calculating the price elasticity of demand, that's the percentage change in quantity demanded divided by the percentage change in income. So if you come up with a number that's positive, meaning as your income goes up, the quantity demanded of the good goes up, then that good is a normal good. It's something that people consume more of as their income goes up. If, on the other hand, you calculate the income elasticity of demand and it's a negative number, that good is an inferior good, meaning that people's incomes go up and people buy less of this product, then it would be an inferior good. Finally, if you calculate this and you come up with a number of zero, what's the only way you can come up with zero in a case like this? Would be if the numerator is equal to zero. So 0 divided by anything is always going to be 0. So if your income goes up, and that doesn't affect the quantity demanded of the good, or if your income goes down and that also doesn't affect the quantity demanded of the good, then that would be a neutral good. Does that make sense? All right, moving on. Cross price elasticity of demand. So imagine that we're talking about the relationship between steak and chicken. So, they could be complements, they could be substitutes, or maybe they're not related at all. Most people would think that chicken and steak are substitutes. If we had no idea, what we could do is we could get data on the sales of chicken and beef, or chicken and steak, and we could look at what happens when we change the prices of either chicken or beef to the other good. So let's say we're calculating the cross price elasticity of demand between chicken and beef. C is chicken, B is beef. That could be the percentage change in the quantity demanded of chicken divided by the percentage change in the price of beef. So if beef goes up and then we wind up consuming less chicken as a result, that would give us, we'd have what, a negative number divided by a positive number. That would give us a negative number. So that would be number one over here. That would imply that these two goods are complements somehow. If, on the other hand, the price of beef went up and people, oops, sorry about that, let me go back. If, let's say, the price of beef went up and people ate more chicken, so you have a positive number divided by a positive number, then we would be down here at number 2, right? And the E sub CB is greater than 0. That's a positive number. That implies the two goods are substitutes. Price of beef is going up, people are consuming more chicken. If, on the other hand, the price of beef went up and there's no change in the demand for chicken, then that implies that these two goods are not related at all. Does that make sense? So this is where the cross price elasticity of demand comes into play. If you're calculating, by the way, let me back up to the price elasticity, income elasticity of demand. If you're calculating the income elasticity of demand or the price elasticity, or excuse me, the cross price elasticity of demand, there's no need to use a midpoint formula. The midpoint formula really only comes into play if you're asked to calculate the price elasticity of demand between 2 points on a demand curve. Here it doesn't make any sense because you've got the demand for chicken in terms of quantity and the change in the price of beef, so they're two totally different variables that we wouldn't necessarily express in the form of a graph. But still, if you needed to do this calculation, let's say just to figure out what the signs are, because oftentimes that's the most important thing, then you could just do a simple percentage change calculation, which would be the percentage change in the quantity of chicken divided by the percentage change in the price of beef. Does that make sense? Okay. Things that would determine the price elasticity of supply. Sometimes there could be what are called supply constraints. And if there are significant supply constraints, then we would expect that the supply curve would be much more inelastic. On the other hand, if there's little to no supply constraints, then we would expect that the supply curve would be very, very elastic. In other words, if there doesn't seem to be any limitation, at least in the short run, on how much we can produce, then we're likely to be more price sensitive, right? A small increase in the price could really get us to produce a lot more. So let's take a look at gasoline prices. I've been using gasoline prices for a long time because when I first started teaching in 2004, the price of gasoline was rising a lot. There were all kinds of theories as to why the price was rising. One theory that was bandied about quite a bit was because Bush became president, Bush 43, and he was from Texas, and he's going to help out all his buddies in the oil industry there, right? The oil industry's from Texas. And because basically what happened in the 1990s, the price of gasoline, you guys are probably too young to remember this, but ask your parents. The price of gasoline basically was within 15 cents of a dollar. I mean, sometimes it'd be around 85, 90 cents a gallon. Sometimes it'd inch up to $1.10 or $1.15. Pretty much stayed that way the entire decade. And then all of a sudden it started rising in 2000. And that's why a lot of people said, well, yeah, the fix is in. Bush, once he got elected, he's gonna pay back his buddies. Well, that's not exactly what happened. As in the 1990s, we were way below our capacity to pull gasoline out of the ground. As we got through the 1990s, we started getting closer and closer to capacity. And so our supply curve became more inelastic. When the supply curve becomes more inelastic, any change in demand is going to show up more in terms of price than it will in terms of quantity. So you started seeing surges in demand caused by China all of a sudden becoming a member of the WTO and being integrated in the world economy. In the United States, everybody had to have an SUV or a light truck or a minivan. And so increases in demand were showing up almost entirely in price and not so much in quantity. I like a good conspiracy theory, but unfortunately, I don't think it quite fits the bill as to why the price of gasoline went up as much as it did. Also, another thing is it fell substantially during the financial crisis. It fell from like $5 a gallon in July of 2008 down to like 275 a gallon in December of 2009. So the only way you could see a big decrease in the price like that would be if the price elasticity supply was relatively inelastic. All right, so I'm going to end it here and then get into elasticity in the tax incident. This is one of my favorite topics, but I want to try to keep these videos reasonably short. Thanks a lot, folks, and I'll be back for the next video.